Right, what is happening first? Define capacitance. Okay. So B2A. So remember you have the formula C equals Q over V, isn't it? So if you were to put that into words, you can say, sorry, I'm going to get rid of this stupid toolbar. Oh. We nearly that, yeah. So, let me make sure I get my spelling right. Capacitance of a capacitor is the... Now, let's just make this technical. You're correct, ability to store charge, but if we just make it a bit more technical, what word do we use for division? Like, no, products for multiply, so what's the one for division? Begins with an R. Ratio. So you could say capacitance of a capacitor is the ratio of charge held to now what's I don't know if I told you this, but a more technical word than voltage, there's another word for voltage. Not that one, we haven't done that one yet, but it's not that. You can also call voltage potential difference. It means voltage. So it's the ratio of charge held to potential difference around the capacitor. But you know, you can use your own words too. You could have said, for example, it's the charge per unit volt. You know, my point is, I'm not going to be super, it has to be exactly these words, strict about it. I kind of basically want to see this formula in word form. But you could even just write the formula down and explain each letter. You know, so it's quite flexible here. Right, next, B. You have three capacitors and they're in parallel. What's their total capacitance? Right, so what's the rule for when you're adding capacitors that are in parallel? It's simply C1 plus C2 plus C3. So here, 5, 6, 7, 8, 9, 10 microfarads. Easy peasy lemon squeezy? Yeah, right? Easy peasy? Now, look at this. And now you connect them in series. What's the total? Yeah, so 1 over C equals, in this case here, it'd be 1 over 2 plus 1 over 3 plus 1 over 5. What's that now? 15, isn't it? 6, 7, 8, 9, 10, 11, 17 over 15? I want 1,000,000 points if that's right, please. Do I get my 1,000,000 points or not? I don't get my 1,000,000 points then, okay. 31 over 30. Okay, so then the C is 30 over 31 microfarads. What's that, please? 0.967 microfarads. Oh, is the next 7, so it's 8 then? 968 then. D, part 1. 31. Oh yeah, but then you have to flip it. Yeah. Okay. Is that okay? So how many marks do we have so far? We have 6 marks. Alright. We haven't done the next part yet. What is the electrical energy stored on the plates? So again, just like with the last question, I have to give you the formula. It comes up in literally the next lesson. So just so everything's together in one video, I'll just give you the formula now. The formula for the energy stored in a capacitor is a half CV squared. So that's a half C. No, it's a different one now. It's 80 times 10 to the minus 6. And then the V is 20. 20 squared is 400. So that's 200 times 80 times 10 to the minus 6. So what's that? 16000 times 10 to the minus 6. So that's 16 millijoules then. Okay. So like I said, this formula here, we're doing that tomorrow. It's just a formula. It's nothing special. Okay, continue. Now, the next part we've definitely done. It's the graph. What's missing from this graph? Can you see that they're missing the log at the bottom here? Yeah. So let's. I'll type it in on the calculator, and you can just write them down into your notebook. So the first one, we need ln of 20 volts. So we'll do 3 digits. So if we do 3 digits, this actually rounds off to 3.00. So 3.00. You got that? The next one is log 19. So that's 2.94. 2.94. The next one is 2.90. 2.90. The next one is 2.83. 2.83. The next one is 2.79. 2.79. And the last one is 2.75. That's 2 marks. The next one is the proof. Do you remember the proof that takes you from V to log V? It's only 2 marks. We still have to do it though. So this is part 2 now. You were told that V equals V0 E minus T over tau. And they want you to simplify that into the log form. So if you remember from your maths class, what happens when you take log of V0 times E minus T over tau? That is if there was no V0 here. This is a multiplication. Which rule of logs do you have for multiplying?
You take it down.
Not quite yet because of the V here. You need another rule first. It's your log AB rule. No. Much simpler. What's log A times B equal to?
Log A plus log B.
So here, this is log V0 plus log E minus T over tau. Now I can do what you said. You can either say log E, this is 1, or you can do what you said is bring that down. It's the same thing, they basically cancel. So you get log V equals log V0 minus, and this probably matches up perfectly, well nearly, they just wrote this part in the front, minus T over tau plus log V0. Yeah?
Is it the same log I?
Yeah. Oh yeah. Same proof, is that what you mean? Yeah. What I'll do later on YouTube is I'll make a playlist for this. I'll call it like Physics Exemplar EOS 1. I'll upload those videos in the playlist, so then they're not mixed in with the lesson videos on the main channel, so you can pull these out more easily when you're practicing them by yourself. Continue. Now the next part is the graph. Now obviously my graph is going to be ugly because I don't have graph paper. I'm just going to do it on this. But I just want to show you how you get the marks. So the first thing, our x-axis is time. Now what are the values for time? Is it in seconds, milliseconds? From where to where? From what value to what value? 0 to 50. So look, that's the time in seconds. Is it going up in tens? Or?
Yes.
So we'll mark off here that's 0, 10, 20, 30, 40, 50. So you'll need to mark this off in the exam. And then you have to put in your y-axis. Turning my page. So that's in, well, it was originally voltage measured in volts, but then you took the log of it, so it's, actually I'll keep it in blue. Voltage in volts, log of that. Okay, let's continue. Now what's the numbers I gave you? What's the biggest value there and the smallest value?
Biggest value is 20, small values.
No, after you took the logs.
Oh, 3 is the biggest value, 2.75 is the smallest.
2.75 is the smallest,
Yeah.
and 3 is the biggest. Right, so we have to be very careful because that's a very small range, 2.75 to 3. So, is that right? Yeah, 2.75 to 3. Okay. Oh, okay. Sorry, I'm thinking greatly about this. I'll go 1, 2, 3. Now this is the problem because my page is quite small. Because 2.75, you see, that would be like there to there. That's not going to work. So what you are allowed to do, you can do this little trick. You can put this symbol here on the y-axis, and that symbol means you're skipping part of the y-axis. That's fine. The only problem with this is it means your y-intercept will be wrong because you've cut off part of your y-axis. Do you know what I mean? It's like you said, okay, I started at 0, but I'm going to skip a little bit, and then I'm going to jump up to 2.75, because otherwise I'll have this tiny little graph up here. So we'll mark off that's 2.75, and we'll go up in 0.05s. So I need to move him out of the way. A bit of space. Okay. Right, so let me think about this. 2.75, 2.80, 2.85. No, that's too small. Okay, let's try again. 2.75, 2.80, 2.85, 2.9, 2.95, and 3. So this is 2.75, and this is 3. And it's going up in 0.05. So that's 2.8, 2.85, 2.9, 2.95. All right, thank goodness. Right, what's the first value, Siba, from the table I gave you? It starts off at 3. Okay. Oh, look at this beautiful work of art. Right, 3. What's next?
Wait, I don't get it,
What?
Well, it's just,
what? 3?
Was the first value I gave you 3? Yeah, yeah. What's the next value?
2.94.
Okay, so at 20 seconds you got 2.94. Okay, next. At 30 seconds?
2.90.
2.90. Okay.
2.83.
2.83. Okay, next.
2.79.
And that's the last one.
2.75. On
It goes.
yeah, sir, because the 10 should be on 0.
Ah, sorry. I'm starting at 0, haven't I? Yeah, sorry. Okay, so it was 3,
2.94.
2.94,
2.90.
2.90,
2.83.
2.83.
2.79.
Okay.
2.75.
Alright, there we go. Look at that. Nice. Now, shall we get the slope here? So the slope, it's negative because it's going down, and it's rise over run, or y over x. So if you look here, this is the, I'll put it in black, this is the y part. That's called the rise. And this here is the x part. That's called the run. Okay, so in this picture here, how big is that? That's about 0.25 over 50 with the minus. So what's that, please? Minus, it's going to be quite small, 0.
5 times 10 to the power minus 3. 3.33. Okay.
Yeah, okay. Oh, I think I'm accidentally doing the next part. So I've done part 3, and now I'm doing part 4. So part 4, I want the time constant. So who remembers what's the formula for the time constant from the slope? Yeah, minus 1 over the slope, isn't it? Yeah, thanks, Steve. Minus 1 over that. 200 seconds. And lastly, what is the value for the resistor? So does anyone remember how to get the resistor? The formula that helps you get the big R. Anyone remember? It's another formula for the time constant. Time constant equals RC. Now we know the time constant. Do we know the C? Do we know? Oh no, there you do. 80. So you know the C. So that means the R equals time constant over C, which is 200 over 80 times 10 to the minus 6. So let's type that in. 200 over 80 times 10 to the power of minus 6. That is a humongous number, which it usually is. It's usually at mega ohms. Yeah, 2.5 mega ohms. 2.5 mega ohms. What did we think of this question now, this electricity question? It's okay? I think it's quite good. How many marks are these section B questions? They're 20 marks, aren't they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17, yeah, 20. So 20 marks should take you how long, roughly? About 20 minutes. So let's see what our time is. Ooh, not bad. We still have 30 seconds to spare. So we're doing okay. You see, you don't have a lot of time to be dilly-dallying, thinking about what to do in the exam. You have to get straight into doing the question. Not a lot of time for thinking and daydreaming and wondering how to do it. So this is what I mean. Even though you have the formula book, can't really be spending your time looking up every formula and every question. Okay. Can I close this? No, you're writing this down. Well, you've gone past 20 minutes, so you can use the 30 seconds we saved from the earlier question.
How long is it?
It's 2 hours, so that's 120 minutes, and there's 100 marks in the exam. So if you spend 1 minute doing 1 mark, it gives you 20 minutes for times when, you make a mistake and you have to redo a question. Even I sometimes do that. It gives you time when you get stuck in a question, you have to think about it for a minute, So you try to aim for 1 mark in 1 minute, and you have a little bit of flexibility if something goes wrong and you have to restart a question. But if you take more than a minute to do a mark, then it gives you no, like no wiggle room. Do you know what I mean by wiggle room? Like no comfort. Okay, can I close this? Yeah? Okay.